Okay, so we will start with the unit number 6, that is architecture of the commercial devices. Okay, now what is basic, what you can say, we will start our discussion with the basic device, that is programmable logic device, that is PLD. Okay, so see, you can take ASIC, you can take CPLD, you can take what you can say, SPLD. These are the all subtypes of the PLD, right? So already we have discussed this thing. So these are the all subtypes of the PLDs. Now what is PLD, or what is basic definition of programmable logic devices? So basically it is an IC that contains large number of gates, then flip-flops, okay, and it can be configured or programmed by the user. This is a very simple definition of PLD. What do you mean by PLD? PLD, it is an IC that contains large number of gates, flip-flops, and that can be configured or programmed by the user. म्हणजे ते आयदर युजरला प्रोग्राम करता येतं किंवा त्याला कॉन्फिगर करू शकता. मीन्स इट्स अ प्रोग्रामेबल, अँड दॅट्स वाय द नेम programmable logic devices. That means user can program that device based on or by using the logic gates. Number of gates and flip-flops means what? These are the logic gates. Means whatever the logic gates that are present in that IC, user can program that logic gates according to the requirement, and that is the PLD. Okay, now basically PLDs are typically built with an array of AND gates and OR gates. Okay, so depending upon what you can say, which one is fixed, which one is programmable, again PLDs are divided into different categories. But basically basic structure of PLD is what? You have an input, then you have a AND array logic, then you have a OR array logic, and finally you have a output. Okay, so this is the basic structure of PLD. Okay, input, then AND array, OR array, output. Okay, this is the basic structure of PLD. Now next thing is types of PLD. Now the same PLD, depending upon the different configuration, okay, that means in some cases both AND array logic and OR array logic are fixed one. In some cases both are programmable. In some cases any one of them is programmable. So based on that, we have categorized PLDs into a PROM, that is programmable read-only memory, then programmable logic array, PLA, programmable array logic, PAL, then complex programmable logic devices, that is CPLD, and the field programmable gate array, FPGA. Okay, so these are the 5 main types of PLDs. Okay, now what is difference between this each type, right? Whatever the category that we have studied, what is difference between that each type? So if you consider the PROM, that is programmable read-only memory, so in that case AND array is fixed one, but OR array is programmable. PROM मध्ये काय असतं? AND array fixed असतो आणि OR array programmable असतो. AND array fixed one, OR array programmable one. Okay, and rest of the inputs and outputs will be there as it is. Inputs आणि outputs तिथे असणारच आहे. फक्त AND array fixed असतो. There are some programmable connections and OR array is programmable. Now what happens? Second type, programmable array logic, that means PAL. In a programmable array logic, okay, and array is programmable, whereas OR array is fixed one. AND array is programmable and OR array is fixed one, that is a PAL, programmable array logic. That means AND array is programmable, OR array is fixed one. Okay, next, programmable logic array, that is PLA. Okay, in PLA both are programmables. In PLA both are programmables, means AND array is also programmable and OR array is also programmable. Okay, now this is what programming means, that means see, so before programming diagram A, you have some logic gates, its fuse are connected, and after programming, if you want to use only B and C inputs, then you can remove the rest of the inputs and only B and C are connected to the final gate. So it's a programming, and that's depending upon your application, right? It's about the programming. Okay, and this is the basic structure of PROM. Okay, in PROM you have a AND array fixed one, and the second one, that is OR array, is programmable. Okay, this is a programmable logic array structure, PLA. In PLA, both are programmable, means AND array is also programmable and OR array is also programmable. This is PAL. In PAL, AND array is programmable, OR array is fixed one. So you can see the structure. Okay, in PAL, you have a fixed OR array and programmable AND array. That means in that case, AND array is programmable and OR array is fixed one. Okay, so this is a typical structure for programmable array logic. See, these are the all types of the PLD, programmable लॉजिक डिव्हाइसेस. हे सगळे प्रोग्रामेबल लॉजिक डिव्हाइसेसचे प्रकार आहेत. त्याचं बेसिक स्ट्रक्चर काय, त्याच्यात अँड अरे असतात आणि ऑर अरे असतात. मग त्यातलं कुठलं फिक्स्ड आहे आणि कुठलं प्रोग्रामेबल आहे त्याच्यावरनं त्याच्या कॅटेगरी आपण ठरवलेल्या, राईट. इफ बोथ आर प्रोग्रामेबल, it is a PLA, programmable logic array. If AND array is fixed one, OR array is programmable, then it's a PROM. If AND array is programmable and OR array is fixed one, then it's a PAL, programmable array logic. Okay, so depending upon that, we have categorized that. Now, the difference between PLA and PL. Okay, it's most means you know this difference. In PLA, both are programmable. Okay, and PAL, okay, AND is programmable where OR is fixed. And now what about SPLD? So it's referred to any simple PLD, usually either PLA or PLA. That means the programmable logic device, right, that can be of PLA or PAL, that can be known as SPLD. That, right, that can be known as SPLD. Okay, now ROM, this is the fourth type, ROM. Okay, see, PROM, that means programmable ROM, but in ROM you have a fixed AND array and fixed OR array. ROM मध्ये काय असतं, दोन्ही पण फिक्स्ड असतात. This is the ROM, read only memory, and that's why the name read only, because we cannot program it, we can only read because it has a fixed structure. You cannot modify that structure, or even you cannot program that structure, and that's why the name read only memory, because both AND array as well as OR array are fixed one. AND array as well as OR array are fixed one, and that's why the name read only memory, that is ROM. Okay, now we have discussed the types of integrated circuits. Okay, now what are the different types of integrated circuits that we have discussed? So basically the integrated circuit is categorized into a full custom ASICs, then semi custom ASICs, and user programmable devices, right, user programmable devices. In again that user programmable devices, you have two categories, PLD and FPGA. In again PLD, you have that PAL, right, PLA, ROM, PML, and in case of FPGA, you have MUX, gates, and lookup tables, LUT. Okay, so these are the basic categories of integrated circuits that are used in VLSI. Okay, particularly these integrated circuits are used in VLSI technology. Okay, FPGA, then CPLD, full custom ASIC, semi custom ASIC. So see, full custom ASICs and semi custom ASIC means what? As the name indicates, full custom means you can customize everything, and semi custom means what? Partially त्याच्यात तुम्हाला customization करता येतं. It is not fully allowed. There is some fixed structure, and partially you can customize that application specific integrated circuit, that is ASIC. And full custom ASIC means what? It's like just a black box. It's just like a black box. Everything you can customize according to your requirement. That is a full custom ASIC. And in semi-custom ASIC, the partially you can what we can say, you can program that as per your requirement. That is a semi-custom. Okay, so this is a basic category of integrated circuit. Now we will discuss about the ASIC. So already we have discussed this thing a lot of time. ASIC means what? Application specific integrated circuit, right? So it's an integrated circuit IC customized for particular use. And very famous and very well known example of ASIC is your mobile IC. तुमचा जो स्मार्टफोन मधला IC आहे that is ASIC because it is meant for that purpose only. बरोबर आहे. मला एक सांगा, तुम्ही तुमच्या मोबाईलचा IC वापरून मीन्स सी ऍप्लिकेशन्स तुम्ही डाउनलोड करून घेता, ऍप्स डाउनलोड करून घेता, दॅट इज डिफरंट थिंग. ओके, बट इट इज बेसिकली मीन फॉर द कम्युनिकेशन पर्पज, राईट? कॉल हँडलिंग, मेसेज डिलिव्हरिंग, राईट? नेट, internet handling. So basic functionality of mobile IC that for the calling purpose and different mobile application running purpose. बरोबर आहे. पण त्याला तुम्ही ऍज अ कम्प्युटर म्हणून वापरू शकता का? नाही वापरू शकत. का? बिकॉज इट इज ऍप्लिकेशन स्पेसिफिक. ते त्या एका ऍप्लिकेशन साठी बनवलेलं आहे, राईट? मग मेजर मोबाईलचे ऍप्लिकेशन्स काय असतात? फोटो, म्युझिक, राईट? देन कम्युनिकेशन, डेटा हँडलिंग, दॅट मीन्स डेटा कनेक्टिव्हिटी. हे बेसिकली तुमच्या मोबाईलचं ऍप्लिकेशन आहे, राईट? अँड दॅट पर्टिक्युलर integrated circuit, that means the IC that is in your mobile, it is a ASIC, right? कारण ते त्या फक्त ऍप्लिकेशन पुरतं बनवलेलं आहे, त्याच्यातनं बाकीचे ऍप्लिकेशन होणार नाही किंवा बाकीचे पर्पज सर्व होणार नाही. इट कॅनॉट बिहेव ॲज युअर डेस्कटॉप कम्प्युटर. नो, इट कांट, राईट? whereas your desktop IC or your Intel processor or your Intel chip, it is not ASIC. It is not ASIC. It is a general purpose, right? You can do anything with that. बरोबर आहे. ते कुठला ऍप्लिकेशन स्पेसिफिक नाही, राईट? यू कॅन हॅव द OS and OS will perform different jobs. You can load many software, different software, some of the photo editors, music editors, anything. म्हणजे it's a general purpose. It is not an application specific. But as compared to that, your mobile IC is a application specific. ते एका पर्टिक्युलर ठराविक गोल अचीव करण्यासाठी ते चिप डिझाईन केलेली आहे, की जी तुमच्या स्मार्टफोन मध्ये आहे. बरोबर आहे. ती जनरल पर्पज चिप नाहीये, एका स्पेसिफिक पर्पज साठी बनवलेली ते IC किंवा चिप आहे. त्याला म्हणतो आपण ऍप्लिकेशन स्पेसिफिक इंटिग्रेटेड सर्किट, राईट? नाउ नेक्स्ट थिंग इज PLDs versus ASIC. Okay, now what is basic difference between the PLD and ASIC? Okay, now the application specific integrated circuit. So this basically ASIC, features of ASIC is a longer design cycle, but obvious because what you can say, if you want to design that for a specific purpose, so its design cycle is also longer. Then faster performance. Okay, it has some faster performance. Then lower cost if produced in high volume. Okay, it has lower cost, right? That is produced in high volume. And what about PLDs? So good for medium to low volume products. If you need more than 10,000 chips, go for ASIC or hard copy. Okay, that means if you want that particular IC more than 10,000 or 10,000 chips, though, then it will be always better to go for that application specific rather than a general purpose. Okay, though what you can say, it is used for medium to low volume product, but if you want to produce that into bulk quantity, you have to go for the ASIC. Then no matter, it will take the longer design cycle, but after once you have completed the design cycle, it will always give faster performance and low cost because you have specified that IC for that purpose only. बरोबर आहे. म्हणून तर डिफरंट IC आहेत ना. You have different IC 741, that is op-amp IC. बरोबर आहे. मग op-amp IC तुमचा DSP प्रोसेसर सर्व करू शकणार आहे का? नाही. you have different DSP processor. DSP processor can't work as a op amp. Okay, so you have different views and different specific ICs that mean for that purpose only. आता for example, तुम्ही you can build a multi vibrator by using op amp also, right? Or you have ready-made multi vibrator ICs also. बरोबर आहे का नाही? तुम्ही op amp वापरून पण मल्टी व्हायब्रेटर्स डिझाईन करू शकता, पण रेडीमेड सुद्धा मल्टी व्हायब्रेटर्सचे आयसी मिळतात. नाही, विच वन यू विल प्रेफर? द रेडीमेड वन. बाय बिकॉज इन केस ऑफ op amp you have to again add some extra components, बरोबर आहे? You have to design that circuitry. Instead, if you use the ready-made IC, your purpose is solved automatically. So that's the difference between the what you can say ASIC and PLD. That means a general purpose and specific purpose. हा त्यातला डिफरन्स आहे. PLD इज अ जनरल पर्पज, ASIC इज अ स्पेसिफिक पर्पज. हा त्यातला बेसिक डिफरन्स आहे. ओके, नाउ available CPLDs and FPGAs. So these are the available CPLDs and FPGAs that are available in market and most widely used for different applications. So basically, Altera is there, then Xilinx. These are the two famous companies or manufacturers that manufacture different FPGAs, CPLDs. Okay, then you have Altera Flex structure of FPGA, Flex 8K, Flex 10K series. Then you have Altera Max structure CPLDs, Max 5000 series is there, Max 7000 is there, Max 9000 series is there. Then when you come to a Xilinx, Xilinx also have manufactured number of CPLDs and FPGAs, XC7000 series, XC9500 family. So these are the CPLDs made by the Xilinx or manufactured by the Xilinx. Again, you have XC2000, XC3000, XC4000, XC5000 series. These are the well-known FPGAs manufactured by the Xilinx. Okay. Now, for your syllabus, you have Altera Flex 10K, then Max 7000 series. Okay, and then Xilinx XC9500 CPLD. So this remaining point we will discuss in the next lecture, and probably we will finish this unit. Okay, in next lecture. So today we will stop here. If you have any doubt, you can ask me right now. कोणाला काही डाउट आहे का? Otherwise we will stop here.